My name is Chad Sanderson. I work for a company called Convoy, which I'm going to talk about in just a little bit. So like Sean was saying, I have a pretty diverse set of experiences building experimentation platforms and programs across late-stage startups, big legacy companies like Microsoft, and very old companies that haven't even migrated to the cloud like Subway. So I hope that this talk will be really interesting for you because it's going to be my perspective on the philosophy and framework around standing up these types of programs regardless of what sort of company you're working for. But for now, we're going to focus mainly on Convoy and how we think about experimentation at scale and bring in some of those other experiences a little bit later. A little bit about Convoy first. Convoy is a two-sided B2B freight marketplace driven by machine learning. On one side of our marketplace, we have shippers, and those shippers are trying to transport freight from facility to facility. And on the other side, we have a carrier, and carriers own fleets of trucks that are taking that freight. Convoy sits in the middle and optimizes it with machine learning. Okay? Now, the CEO of Convoy is Dan Lewis, and Dan is coming from Amazon, and as I'm sure you guys know, Amazon has a really awesome experimentation culture, and he brings that with him to Convoy. So my job and our job as a data platform team is to enable every product team at Convoy to do experimentation in a self-service, rapid way. And because of that, we did a huge evaluation of experimentation products back in about 2018 before we decided which way to go forward. And the TLDR of the entire presentation, really, at least for me, is that the existing experimentation platform technology currently serves a very specific customer and a very specific use case. And that use case is super high traffic websites, tons of samples that focuses on clickstream events. So that's things happening in your front end, your applications, websites, mobile apps, things like that. So if you fall outside of this use case, the current stack doesn't really help you that much. So what I would advise, one of your main takeaways of this talk should be, is that instead of asking the question, how do we run A/B tests? What's the platform that we need in order to run A/B tests really quickly? You should start asking the question, how do we measure important things, and what are those important things? So I want to talk about the framework that I used when setting up the experimentation product and program at Convoy, and how that trickled over into some of the other places that I worked at. So the first place to start is use cases. What are the measurement use cases and the experimentation use cases that are very, very important to your business specifically? The first thing we need to think about within use cases is what makes Convoy unique as a company. And like I already mentioned, we are an ML-based B2B marketplace startup. And there's a few important things to think about there. The first one is that we have a lot of models. We have a pricing model, we have an ETA model, we have a relevance model. And those models are iterated over very, very quickly. So whatever our solution is needs to be able to handle a very high volume of iteration on machine learning models. That's number one. Number two is we're a B2B marketplace. And when you have a two-sided marketplace, it means that just randomizing on your typical entities, like randomizing on customers, is going to cause bias on the other side of the marketplace. So you need to be able to randomize on entities that are outside of that traditional CDP framework. So for us, that would be geographies, regions, time, stuff like that. And then finally, we have very, very small volume. And oftentimes, not only are we trying to optimize the customer experience, we're also trying to optimize our operational efficiency. So we have a small amount of customers, shippers that are really, really important to us, like Walmart. They're trying to move some freight, and we need to make sure that they don't get really angry at us and don't want to ship freight anymore. So we need to make sure that our ops team, which is a non-automated part of our business, is super efficient. So all those use cases I just listed are on the left over there under the Convoy column. But those use cases are really, really different from what I experienced at Microsoft and at Subway. So at Microsoft, we didn't just have one product. We had a ton of products, and many of those products were sort of stitched together in weird ways. So Bing, Office, Teams are huge, right? These are millions of customers, sometimes hundreds of millions of customers or entities, truly enormous sample sizes. That means if you know anything about experimentation, You're going to get very, very small results very quickly. We don't have that issue at Convoy. Some of our products were ML-centric. Bing, right? It's a ranking algorithm, so you're running experiments on that all the time. But Xbox is a lot more focused on the product experience. And in Microsoft Store, you're really focused on marketing, right? Conversion funnels. And then finally, a big difference was that safety was a really core priority, right? When you have hundreds of millions of customers, and many of those customers are leveraging Microsoft products in critical workflows, they can't fail. If they fail, it's a huge, huge problem. It's a big deal. It's a problem that we don't have at Convoy right now. So ensuring that things are safe and not breaking was equally as important as like this new feature is making money. At Subway, similar issue, a little different. We had a website and we had a mobile app, very small sample sizes, massive sample sizes in the store, huge foot traffic. In fact, Subway is actually the largest franchise by volume quick service restaurant in the United States. A little fact for you. Zero machine learning, none at all. Everything is going through either the marketing website or what's happening in the store. And so the main focus there is figuring out how do we message our new sandwiches and wraps effectively. Very, very different use cases to think about. Next is metrics. So we've got our use cases, but what are the things that we actually need to measure in order to demonstrate value and ROI from our experiments? Convoy is a startup. That means we have to prove to our shareholders we're growing very quickly. We also have to prove that we're margin positive, right? We're not building products that like fundamentally don't scale. So growth-based metrics are super important. Financial metrics are super important. And those financial and growth metrics have to be very, very accurate. They can't be super wrong. And that means we need to go to the source of truth, which is the data warehouse. So when we are creating metrics, we need to be able to write queries against the data warehouse. For example, margin, variable cost per shipment, and the price of shipments relative to the market. We don't want to be overbidding or underbidding on shipments. But same issue here. We have all these experience metrics around growth, number of bid intents, was the pickup on time or not, how many minutes did a carrier actually spend taking a particular piece of freight. We have all the financial metrics I mentioned. And then we also have the operational efficiency metrics that I mentioned before. So how many inbound emails are we getting? Are we able to reduce that? How many quotes are we getting? How many of those shipper issues are turning into escalations? Microsoft, very, very different, right? Being focused primarily on advertising, right? Ad results, how many people are clicking on these ads, what are we showing, what's the relevancy of them? Office was focused on the product, how many documents are being created, saved, edited, and so on. And on the store, it's more like conversion rate optimization. So are we getting people through that pipeline very quickly? For Subway, we also focused a lot on the marketing side, so that conversion optimization funnel. But we weren't primarily interested in getting people to buy a lot of things. What we wanted to do was take our customers that were in the store and convert them to loyalty members and upsell them. That was the main focus of the experimentation, some of the experimentation on the website. But we also cared about metrics in the store itself, with the number one being mix. So Subway releases a whole bunch of new sandwiches and wraps and drinks and combos and things like that. And what they want to measure is, when they do that, are those new items then represented in whatever the mix is of that store by region? So we had to be able to measure that very accurately. And then finally, we come to the organizational setup for experimentation. In Convoy's case, like I already mentioned, this was part of the DNA of the company. So your promotions are based on experiment results. Whether or not a feature is shipped is based on experiment results. And because of that, we needed to give everybody the power to serve experiments very, very quickly, and the data had to be right. If your promotion is based on an experiment, the data can't be wrong. That's going to be a huge issue. So our focus was on self-service and accuracy. But again, at Microsoft, big difference. Many different companies, different stages of maturity. Some of them knew what experimentation was and prioritized it really highly. Some of them didn't do any experimentation at all. So that means that we needed to have a centralized team, and that centralized team acted as a locus of customer success. We were enablers. So sometimes we're actually building the pipelines for teams. Sometimes we're just advising on experiments. Sometimes we're even coming up with experiment designs. At Subway, we had no data scientists. Nobody knew what experimentation was. I was introducing it to the company for the very first time. And so our team, our experimentation program group, we did everything. We designed the experiment, we built it, we developed it, we deployed it, and we analyzed it. Okay? So from Convoy's perspective, an ideal technical stack has these attributes: assignment, metrics, and analysis. Assignment is, how do we randomize the entities that we really care about? We needed feature flag abilities. We needed to gradually deploy these types of changes. We needed to filter entities down to specific personas we cared about. And we needed to trigger experiments on certain events. On the metrics side, we needed the ability to compute metrics in the data warehouse in SQL. That was a huge requirement and use case. And we also needed to be able to discover those metrics really cleanly and efficiently and have that metric repository act as a source of truth. And then on the analysis side, we had a whole bunch of statistical use cases we needed to facilitate. And that meant supplying a range of algorithms and visualizations and segmentation capabilities. So what that practically looked like was something like this. These are all the applications in each area. On the assignment side, we had more customer-ish entities like carriers and shippers, but we also had trucks, RFPs, and shipments. On the metric side, we had click events, but we also had financial events, operational costs, shipment duration, service failures. And on the analysis side, yes, we did basic things like Ttests, but we also did pretty advanced things like causal impact and downstream impact. The modern, or the current experimentation tools, though, when we did our evaluation of what existed, really only provided us this, right? So we were able to randomize on customers, carriers and shippers using our front-end applications. The metrics that we recorded were from clickstream events, and the analysis that we could do was limited to Ttests. This is obviously like a big problem, right? This is like 75% plus of our experimentation use cases are not supported. So how much value does A/B testing really have? So the core problem here is that what we observed, even after this audit, was only the tip of the iceberg for experimentation. Convoy is going to grow. There's going to be more product surfaces. There's things that we didn't even cover. I didn't talk to the sales team very much, for example. So what we really needed was a flexible platform that allowed us to randomize on any entity, compute any metric, and perform any type of analysis that we wanted. And like most engineering teams will tell you, what that typically results in if you have a huge gap in what you need versus what exists is you just build it yourself. So we built it ourselves. It took us 4 engineers and multiple years of effort, and that effort is still ongoing. But the good news is we solved the problem, right? And we're actually enabling experimentation across every single corner of Convoy today. So the big use case here that I want to leave you with is make sure you're structuring your experimentation system around the business use cases and the needs, and not a generic application of A/B testing. Don't just follow the crowd. And if you select the wrong tool at the wrong stage of your customer's lifecycle or your business lifecycle, then you could be limiting the value of experimentation for years to come. And with that, I'm going to pass it over to someone who is working on solving a lot of these problems that Convoy focused on, but spent engineering time. That's Jay with Eppo.
I got the mic here.
Oh, he's got the mic.
Cool. All right. Thanks, Chad. So as Chad mentioned, I'm the CEO here of Eppo, and what we're trying to do is take the same concepts that he was talking about, measure what matters, and measure it kind of in a democratized fashion, and making that available to people who are not going to have the experimentation teams of Convoy. So I'll start off with a quick background about myself. I'm not going to read all these things, but I think the main call-outs, I was pretty early at Airbnb. I saw a lot of that journey, both from a data technology standpoint as well as a data culture standpoint. But crucially, I also went to a bunch of other places and saw kind of difference in metrics, the difference in organization, the difference in goals. Most recently, that was at Webflow, where I was the second data scientist. But before that, I also had my logistics stint in Next Trucking, and so got to experience that a little bit. My head of data eng comes from Snowflake, so he brings a lot of the kind of database type of backgrounds. But a big thing to realize is that when we built experimentation at Airbnb, this was a different era. We had to do it with a bunch of open source distributed compute platforms like Hive and Pig and stuff like that. Nowadays, no one has to do this anymore. We have this modern data stack that I bet most people in the room are now using, which is we have some combination of Snowflake, Redshift, BigQuery, and then a transformation layer atop like dbt or Airflow. And then there's now an increasing constellation of tools around that. And so with that, you can start doing things like experimentation really early on. So most recently, I was at Webflow. That was a Series A company, and we were running all these experiments. And with that, and the reason why so many people run experiments, it's pretty obvious for anyone who's been part of these programs, is experimentation starts to open your eyes to this basic fact that you're shipping all these things, and you think they're all fantastic. But it turns out around a third of them are actually good. And this is a success rate that's been corroborated in a whole bunch of environments. So at Microsoft, Bing, Google, Airbnb, Netflix, there have been papers published about it, that basically of the things you launch, only a third of them are actually very effective. And so if that's the case, then you really need to know what third is happening at a given moment in time. So the companies that realize this do the Convoy thing, where we build this big in-house system, throw engineers at an internal tool. The Airbnb one we built is on top here, but many of the other unicorns have their own. And under the hood, they all have this architecture. This is basically the architecture of every single experimentation system in existence. And in this talk, I'm actually going to go deep on each one of these components. And the thing I want to really make a takeaway is that experimentation is really, like under the hood in terms of infrastructure, it's around a bunch of different components that are each have a bit of depth to their complexity, and they all have to work in concert to get the ROI you want. So this talk is going to be about going through every single one of these components, talking about their failure modes and opportunities for impact to make your program more successful. Starting with the randomization side. Now, the randomization side is typically what most people think of as what experimentation is. And so there's actually a decent amount of commercial tooling around how to do it. Under the hood, all commercial tooling looks like this. So whether it's a LaunchDarkly or kind of most in-house tools, they all have a way to convey experiment configurations saying like, here are all the experiments going on right now. Here's how the allocations are 50-50, 40-60, whatever sort of thing. And these experimentation configs are being synced onto clients, let's say every 15 minutes or so. And they need to be served fairly quickly. I think the modern principle is to use CDNs around them and kind of in the background kind of consume the configs. And what that does is with these experiment metadata stored locally, now it's a very quick, low latency process to then split users into different groups. And typically you have some sort of function, let's call it get variation, get treatment group, whatever it is, that you can call. And that's the main DevRel experience of most engineers, is that they don't have to worry too much that there's this underlying SDK that's syncing things. They just say, hey, here's the experiment going on, put me in a group. And that function also, crucially, is going to spit an event back to your warehouse and say, this person is in this experiment. So there's kind of iterations on the underlying technology, but this is the basic framework of it. And another big thing is when you do this randomization, the kind of best-in-class way to do it is MD5 hashes. That has a nice property where you can do it offline, you can do it online, you can replicate how it's going to be randomized, and it's just always going to do the same thing. It's idempotent. So if this user hits the same experiment 10 times, they're going to end up with the same treatment group. So this is the randomization side. And I've been at many companies where they started off by randomizing like the last digit of a user ID or something like that. There are other ways to try to get started, but what's tricky is some methods, like if you call a rand function, are not idempotent. You can't just get the same thing every time. And some methods like last digits might not be as random as they think. And especially if you did what we did at Webflow originally, where 0 through 4 are always treatment and 5 through 9 are always control. And so you have a long-term set of guinea pigs. So this is kind of where most companies end up. Then we have the metrics side. And this is an area of passion for me, because I think this is something where a lot of experimentation programs mess up. And I think the biggest takeaway that Chad touched on already is experimentation programs get a lot more powerful if you use business metrics. So I see so many companies, they start off running experiments, and they just use the metrics that are kind of available with the existing tooling, which tends to be like click conversions, like someone signed up, something like that. And yes, you can boost those metrics, but it's not really going to get many people's attention that you boosted signups. Like you really want to show that you boosted revenue or bookings or purchases. The kind of quick sentence I always say is like, if you showed this experiment result to your CFO, would they care? And that's actually going to be a big deal because it determines like, who gets resourcing, how this all falls out. So to get the real value of experimentation, you want to use Stripe data or data from all the different points of sale. So in the end, it basically means you need to connect to the warehouse. The other thing I want to mention is because people are so used to taking these shallow click metrics, they usually look at steps kind of higher up in the funnel. So again, I mentioned signups or like filling out a form or something like that. But I just want to let people know about a certain pattern that we saw over and over at Airbnb and at Webflow, which is that the vast majority of experiments will boost one part of the funnel and then depress the other. And they'll end up right neutral. And we saw this over and over in the search funnel. Just back in the day at Airbnb, you had to first request a book before you got accepted. And so you'd search, you'd contact a person, then they would accept, and then you could do a booking. And almost every experiment would inflect one part and make the other one go down. So this is another reason to use business metrics, because then you can at least have confidence that you're not just like kind of playing whack-a-mole with funnel. Now we have the sufficient stats part. And it's called sufficient statistics because that's what you're actually calculating to fuel your analytics results. But it's really a big data engineering problem. So this is the DAG that most pipelines end up working with for experimentation. So on one end, you have those assignment events that I talked about from the randomization system. On the other end, you have these metrics, these fact concepts, such as a purchase, such as you got revenue. And then you got to join them together to say, of these different purchases, how many were part of this experiment? And then from there, you kind of group it first to an experiment subject level and then an experiment level. The thing I really want to emphasize is that this DAG, all the action is really in that first join. It's basically a big join and then 2 group bys. And the group bys happen pretty quickly. Most data engineering teams don't lose a lot of stress or compute around the 2 group bys. But that join, it's so large that if you look at Airbnb in its experimentation program, somewhere around like a third of all compute cost is happening with this experiment join. It's like a very big deal. So it's most of the optimizations end up around there. Then we get to the statistics tests. And this is the part that it gets a lot of play in the discourse. The academics get involved also because they do these sort of things. And there's kind of a holy wars between frequentists and Bayesianism and stuff like that. The thing I want to mention around stat tests is that most programs, I would say like 95% of experimentation programs, basically just run a t-test. And while this isn't necessarily wrong, it puts a lot of onus of expertise on your organization because there's a bunch of failure modes for t-tests. Specifically, if you run a t-test, you're not supposed to look at the results until it's done. So you make this promise saying that like we're going to start out this experiment, we're going to run it until we have 1,000 samples in both groups, and then we're going to look at the results and make a decision. Now, anyone who's ever run an experimentation program knows everyone looks at this every day. Like no one's actually going to not look at the thing for weeks. And so that already is just inviting misuse when you use these t-test methods. And then there are a bunch of other failures to deal with outliers and the types of metrics you're using. Specifically, once you do ratio metrics, you can no longer use the t-test. You have to use a thing called the delta method. There's a bunch of things that people don't fully realize, and in the process, they just suddenly incur a lot of false positives. And so the thing with t-tests, simple to implement, pushes a lot of expertise and required hand-holding onto your experts. In comparison, I'm going to tell you about a few other things that might help. So one is there's a method called sequential testing. So this is what Optimizely uses. It's getting a lot more play recently. And what it mainly touches on is that the t-testing operates with this kind of static decision boundary. That's saying like if the p-value is below 0.5, it's going to trigger. But the vast majority of experiments kind of look like this, where they will intermittently be significant and then regress back to normal. Whereas a sequential analysis, what it does is it has a more dynamic boundary. And it says that like early on, if it's a really large effect size, sure, you can have a significant result. But over time, that's going to narrow into something that converges more. And this has a nice property because it just builds in the idea that you're going to look at it every day. Like it just embraces that these organizations are going to potentially call the experiment on any given moment in time. And so boom, you've already removed the whole like hold people's hand, make sure they don't look at the results early thing. Other ways that can really help out your organization, there's a whole class of problems called variance reduction, of which the most well-known is Cupid. And I always bring this up because people don't realize that with advanced statistical methods, there's actually free money out there to make your organization run faster. Specifically, you can take these experiments that take something like 2 months, and they can actually run in, let's say, a month and a half. You can kind of save 2 weeks of product time, increase your learning rate. It delivers a lot of value. And it's one of those rare kind of free lunch sort of situations where, like, if you have the know-how to implement it, you actually just win. The way I explain it is I have this one analogy around, suppose you're McDonald's, and suppose you're running an experiment to boost the sales of Happy Meals. The easy way to do it is to run some experiment and then see, did the number of Happy Meals go up? But there's actually this interesting insight you can say is that suppose every time someone walks in the door, you're going to make a guess on if they're going to buy a Happy Meal. And then you're just going to compare how they did against their guesses. Now, if you did that paradigm, you would say stuff like, well, if someone walks in with 3 kids, I think they're going to get a Happy Meal. Like, whereas the kind of person stumbling in with a hangover, like 40-year-old, whatever, is probably not going to get a Happy Meal. Or even more obviously, if someone previously purchased Happy Meals, they're probably going to purchase a Happy Meal. And so what this means is that suddenly you are taking account for some natural variation and just kind of removing it from the equation and getting a lot more signal. So in practice, it's really just a linear regression. It's not actually anything super fancy, but it does mean you have to get kind of metric calculations before the experiment, get the history of the person. So if you look at a place like an Airbnb or a Microsoft or a Facebook or whatever, they've all implemented this thing. It's become a mainstream method. It's just because it involves some more complexity, both on a data engineering standpoint and a statistics standpoint, you don't see it in the commercial landscape. Then we get to the issue of diagnostics. And this is actually one of those experimentation at scale things where there's just a lot of failure modes that happen in experimentation and that you have to make people aware of and make people correct for it. And the best way to understand this is, I don't know who all knows Ranin Kohavi, but he was a major influential person in terms of taking experimentation to the mainstream and especially emphasizing the platform version of it. Like the whole organization is going to use this platform. The first word on his book is trustworthy. And experimentation is really a big leap of faith of saying, like, we're going to let this system adjudicate who wins and who loses. So trust is like the big underlying principle of all of experimentation. So in terms of diagnostics, far and away the most common failure mode is imbalanced treatment groups. And this is where you think it's a 50-50 split. It's actually, let's say, 52-48 or something like that. And the problem is that difference is almost always a canary in the coal mine, that there's actually an underlying issue. Because the type of people who are getting imbalanced that are throwing off this 50-50 split, they're probably people with low latency. Maybe they're in a low connectivity area on their phone or something. Or they're on a client that is generally completely broke, but it's just a low percentage of your traffic. So at Airbnb, there weren't that many Android users for a while, and so maybe it was just really broken on Android. And so the way to check for this, there's a thing called the sample ratio mismatch test. Most people would run it as a straight chi-square test, but there's another sequential version that you can run every day. In my experience, every time there's an imbalance, it's always an actual problem. It's never something you can kind of quickly brush away. So if you look at mainstream experimentation tools, they all build in this check as part of day-to-day practice. So that's diagnostic number 1, imbalanced treatment groups. Number 2 is outliers. This is one of those sneaky truths in the world of data science that I wish we'd all talk about much more commonly. Who here has heard of Nassim Taleb and the Black Swan? So Nassim Taleb, kind of fiery figure, has a lot of opinions that you can get into Twitter wars with. But the fundamental principle he talks about is that social phenomena metrics follow power laws. They do not follow these kind of finite moment distributions that basically all of modern statistics are built off of. And people who work at companies, you all know this. You all have some level of outliers that are just completely skewing things. So at Airbnb, we had these hosts that we called whale hosts. Now, by and large at Airbnb, most hosts are just your typical mom and pop with an extra room sort of thing. But there were some hosts who aren't just people. They are corporations that run a large portfolio of Airbnb homes. And these people drive so many bookings that if you were to just randomly divide people into two groups, they would actually drive all the results because there would be slight differences in their allocations between the two groups. And then the same thing happened at Webflow. Webflow is a no-code website building platform, and there were some people who were not just your freelancer type who's building websites for people. They were a full agency. They exist in many countries. They were building tons and tons of websites. And if you just naively split them into two groups, they're again going to drive all of the outcomes. So outliers, it's a tough thing because these power laws generally break modern statistics. There's a few ways of dealing with them. The kind of classic way that in academia you do it are non-parametric tests. So basically say, like, we're not going to have any assumptions around distributions. We're just going to use ranks and stuff like that. In practice, these are the two things I see. One is Windsorization, which basically says take the 99th percentile and just take that as the maximum amount of this metric. The other is that method Cupid I mentioned. Because it accounts for prior history, it can actually take out some of the outlierness of the outlier. And then this last one, I'll touch on it really quickly. But one of the things about experimentation is it makes your underlying data quality issues invisible. So typically, if you have some sort of, like, your data's not updating or there's some day that's missing data, you look at a line chart of it and it's just broken, right? And it's just obviously this is bad. When you look at experiment results, it's equally broken on both sides. And so it kind of just looks like an experiment result. And so making it really easy to know if data quality is bad is, a big deal. So then in terms of investigations, I'm going to go a little bit quickly here because we're kind of nearing the end. But I think one of the things every experimentation practice learns is that getting to a place where you're delivering wins is a learning process. First, you have to be able to run an experiment at all. And I've been part of teams that have an OKR that's literally like run an experiment, like at all. It's just getting all these pieces to work together is tough. But then when you run these experiments, you quickly realize that you have all these bugs. You built this thing, but you didn't consider this one use case, or you didn't consider Android properly or whatever. And so you have to learn to diagnose quickly. And then you can actually get to a point where you reliably deliver wins. And the most important way here to discover these issues, to learn, is to be able to segment results. So at me, back in the day, this was a really common situation. You'd run this experiment. It looks good. It looks like an overall negative-ish problem. But once you split it by something like browser, it turns out it just has a big IE bug. And it was actually a good one, but it was just failing for that reason. So this can also happen in Webflow with different user personas. The big takeaway is to say you need to take your results and be able to split them by user segmentations. Make it readily available. Make it democratized. This is a big part of being able to understand experiments. And then at the end, we get to this reporting side. And I really feel like reporting is the most underrated part of data science. Because you do all this work, all this complexity, and in the end, you're supposed to drive a decision in the org. And that last mile of data science is really communication. To give you a sense of what I mean, I just Googled experiment templates in Jupyter and Looker and stuff like that. And this is what I found. It's a big pile of numbers, a bunch of charts that you don't really understand. And this is, having done a lot of customer research, this is the state of the art of most companies' experimentation programs. So basically, what you end up doing is building in the concept that a data scientist has to translate it to you, like a Rosetta Stone or something like that. It's like this big translation process. So I think most programs, it would behoove them to think, what is a form of reporting that doesn't assume so much context and knowledge? It doesn't assume you know what a p-value is. It doesn't assume you know what these warehouse tables are, or what these metrics are, or what is the right way to look at revenue. Just really try to simplify things so that if you just threw like a junior PM straight out of college in here, it would actually be able to make a decision. So that's another piece of getting experimentation to scale that I think is just hugely underrated. All of this is part of a general flywheel you're trying to get going, where you start off, you get one team to try out this new workflow, try running an experiment, expose yourself to metrics as the main decider of winning. And then once you kind of go through that, you build up the infra, you build up the know-how, you build up those muscles. And this eventually hopefully turns into something like an Airbnb-sized experimentation program. But all of it really comes down to getting all of these pieces to work right in a way that matches your business, like Chad is saying, and can be wielded by many people in the org. So yeah, I'll stop there. Thank you all for coming to our talk. My name's Che. Here's my email and Twitter account. I'd love to hear what you think. I'd love to talk about experimentation anytime. I especially love hearing kind of how it plays out in different environments, different business models, different maturity stages. So yeah, with that, we'll wrap.